Welcome Engineering Science, Mr. Young here again, just looking at another energy, this time kinetic energy. This is a move on from work done, which was the amount of energy a body or an object can do. And the last one before this was potential energy, the kind of energy that's stored in an object ready to be used. This time we're moving on to kinetic energy. We'll see how that differs from the ones previous there. So we'll be looking at the kinetic energy formula, how to manipulate the formula. So to find out different aspects of it, or different areas of it, and be able to kind of, again, be able to kind of simplify large numbers that you might find from calculating some of these numbers. Okay, the one important thing to note is kinetic energy. How this differs from the ones previous is that kinetic energy is referred to as the energy of movement. So anything that's moving, any vehicle, person, object that's moving will have kinetic energy. Okay, so what we're looking at is kinetic energy formula is shown as EK. Now again, keeping it standard as before, having the E for energy first before the letter for the type of energy it is. So it was EP before and it was EW. So this is now going to be a kind of standard thing that you'll see through the other energies that we're going to look at, which is electrical and heat. So again, energy measured in joules. We've got mass here again, which is measured in kilograms as before. We do have a velocity this time, because obviously this is an energy of movement, so an object will have a velocity to it. That's measured in meters per second, and what you have to just be aware of is velocity squared. Okay, that's what that V2 means above the V is velocity squared. So what you're looking at is that when you're multiplying a velocity, you're going to square it. So if I say that a bike has a velocity of 10 meters per second, it's 10 meters squared, 10 meters per second squared, or 10 times 10. Okay, you're multiplying the number by itself, and hopefully this will become a bit clearer as we go on through the examples. This half is just a half, is 0.5, that's all it is. It's not half of the mass, it's not half of the velocity, it's just a half. I'll try and maybe show you a couple of different ways of how to maybe use that in the formula, just to make it slightly easier, slightly more manageable, and to check your answers as well. Okay, so it's the energy of movement. So the kinetic energy formula is a half times the mass times the velocity squared. Okay, and now I'll show maybe about 4 different ways in how this could be used, and any pitfalls and wee tips and hints and tips I can give to kind of make sure you can work out these problems. Okay, all right.
So can you see here I've got a couple of examples here, 3 examples in fact of kinetic energy that we just discussed before. Got the formula back in here. Again, kinetic energy shown as EK, the energy of movement. So again, keeping everything standard with using the E, the capital E first for the energy to represent the energy, and then the small letter to represent what type of energy it is. In this instance here, hopefully you can see it okay, is a car with a mass of 500 kilograms has a velocity of 10 meters per second, and we're going to work out its kinetic energy. So working out kinetic energy, so we're going to take a half times the mass times the velocity squared. Now this is just a half, it's not a half times the mass, it's just a half. Okay, so we'll deal with that as we go along here. And there's a couple of ways actually you can do this. EK equals a half times 500 times 10 squared. Okay, and what I've done is I've put the velocity in brackets there, because what I want to do is deal with that on its own. If you happen just to go a half times 500 times 10 squared, you'll end up squaring the whole thing, and your numbers will be way off. It'll be wrong, basically, your calculation. So looking at half times 500, then half times 500 times 10 squared is 10 times 10, which is 100. Okay, there's a couple of ways you can work this out there. So that's what we're looking at so far. So now we're going to work out the rest of it. So a way to do this is you can say a half times 500 times 100. So a half times 500 is 250 times 100 is going to give you 25,000. Or you can multiply these two out first. So 500 times 100 is 50,000 times a half is 25,000. So whatever way you work it, it's still coming out to be the right answer. So in this case, we'll do 250 times 100 equals 25,000 joules, or 25 kilojoules. Another way of working this would easily be EK equals mass times velocity squared over 2. See if that works out as well. So that's 500. I'll move this over a bit. Times 10 squared. Try and put that in brackets again. Right close to the edge of that page, aren't I? So divided by 2. So 500 times 10 squared. So 500 times 100, 50,000. Divided by 2 is, surprise, surprise, 25,000, or 25 kilojoules. So it still turns out to be the same answer. So there's different ways you can work it. And in fact, it'd be good if you, once you've done it, is to check it the two different ways, either doing it that way, just to double check your work, even if it's just a quick calculation, or doing it the other way, like doing it the 500 times 100 times a half, and see if you get that same answer. So I've got the answer twice, so I'm quite happy with that actually. For the second one here, we're looking at a donkey this time. It's good that I make all these things up. It takes me ages to think of animals and creatures and that. Let me move this over just a touch here so you can see the question. So it's got a kinetic energy. It's got a velocity. What we're looking for this time is to find its mass. So this time what we're doing is we're holding over the mass and we're looking what's left. The kinetic energy on top here, and we've got a half and velocity squared down the bottom. So this is going to be, for finding the mass, is equal to EK, kinetic energy, not E Kilbride, is a half times V squared. Okay, because that's on top. Once we take this out, this is what we've got left on the bottom. So it's the kinetic energy divided by this. So we'll equal that. We're going to have the 280 divided by the half times 5 squared. Again, we're going to deal with that on its own, so that's going to be 25. So 280 divided by a half times 25. I know there's not a whole lot writing here, but I'm doing it purposely on wee steps so that you can actually see that, what's happening. A half times 25, 12 and a half. So 280 divided by 12 and a half will give us our answer. So 280 divided by 12.5, and will give us our wee answer here, which will give us an answer of 22.4 kilograms. Remember, it's mass, so kilograms. Make sure you put your units in. So not too bad so far. We've managed to figure out a kinetic energy one. We've managed to figure out what it is with mass. We're looking for the mass of something that has a kinetic energy. Next, what we have to do is look at the velocity. So for the velocity one here, you can see it's attractive this time. It's got a mass of 850 kilograms and it's got a kinetic energy of 1.25 kilojoules. So maybe the first thing we need to do here is figure out what that is in normal joules. So you're times them by 1,000, so 1250 joules. Okay, just multiply that by 1,000 to get your joules. What velocity is the tractor travelling at? So this time, covering over velocity, we'll see what there is. Kinetic energy again on the top, it's not moving, divided by a half times the mass. So V squared is equal to kinetic energy divided by a half times the mass. Okay, in this case 1250 divided by a half times 850. Right, so you can figure that one out now. And that'll be 1250 divided by 425. So it's going to come out to be just under 3 or something, isn't it? Around about 3 here for this first bit here. So we've got here, when you divide 1250 by 425, you've got 2.94. Now that's not the end of it, because what you've got here is that's the V squared. Okay, the velocity squared. We just want the velocity. So to get the velocity, we need to take this squared over the other side. And when we do this, it's actually going to square root it. So to find the velocity on its own, it's 2.94 square rooted, right? It's the square root of this number to find the velocity on its own. So we do that, and that will give us an answer. That will give us an answer of 1.7, actually, 1.71 meters per second. It's a very slow moving tractor. But if you get to this point, and you've done the sum, and you get to this point, remember it's the v squared you've still got there. It's the velocity squared. You just want to find the velocity. You'll probably get a couple marks for this, but if you don't do this last bit, you'll lose out in a mark at least. Okay, one last one. It might throw up every now and then. It might come up here. Is that sometimes you'll be given a question like this. So you've got a distance, and you've got a time here, and you've got a mass. So you've got a mass. You asked for the kinetic energy, but you'll be thinking, well, how do I work this out? Because I don't have a velocity, so to speak. Well, you're right, you don't have a velocity, but what you would have, you've got a distance and time. So actually you can work out the velocity is equal to distance over time. It's a speed equation. I know that some people are going to be saying that's for speed, but you can still use it for this one as well. In this situation, I know that's probably not ideal. 100 meters divided by 5. Okay, we'll give you your velocity in this case here in meters per second, won't it? Which is equal to 20 meters per second. And then from there you can work out the kinetic energy equals half mv squared, mv squared. So half times 85 times 20 squared. So then again we can work this out. And it will give us an answer of 17 kilojoules. Okay, so 4 different ways of working things out. It might be very rarely that you'll get this last one here, but you just have to be aware of that kind of situation maybe cropping up there. More likely in an exam you'll be given a straightforward kinetic energy one. You might be given a second part of the question that maybe forces you to work out the way working from v squared just to the velocity again. So you just have to be aware of that. Okay, so as always, that's how to use kinetic energy. If there's any questions on that, you can let me know. But hopefully, as I will say at the end here, thanks for watching and please stay safe.